read the question now. Something related to vertical circular motion. I brought a situation. The bullet will go in, collide with the ball, and gets embedded in that. Inelastically. This is some. So that after collision, the ball is just able to complete the circle. What should be the value of velocity of the bullet and the value of speed of the ball just after collision in the lowest position of the circle? I think something, if you get velocity of bullet, the other thing we can find out. And get the sequence of the diagrams, small diagrams you draw it. What actually happens? So what is initially they are at rest. The system is at rest. Maximum concentrate on numericals of application. You do initially some collision basic fundamentals, then come for directly application. Collisions in projectile, collisions in laws of motion, collisions with friction, collisions in, like earlier we took one spring, no, like that. Then center of mass and collisions in circular motion. What all till now the topics covered there, how that collision problems can be applied here. This is what you have to search in numerical. Now, let me just put what actually going on here. I'll draw some rough diagram, not like a free diagram like this. So there's a trolley. It will be, let it be like this. Then there's a rod. And there's a string. So there's a ball. So there's having a mass m. There's a mass m, and a bullet now approaches with a speed v. This is also having mass m. It gets collided inelastically. It collides, so it gets stuck to it. So together, so what is the mass of this system will be now? Now it will become 2m. Now this is now here is what your troubles will start. There's a rod, it's a light. Just after impact, only this will be moving, no? Only the bob will have velocity v1. What about the trolley? Trolley will be still at rest. Just after impact. After certain time, what happened? Now as the bob swings, the string will make an angle theta with vertical, then a tension will act. So here, let me. In your mobile, you can magnify the screen and make observation. Because I want to show the total sequence of the problem. That's why I'm going for small diagram. So the moment collision occurs, there's a diagram. After some time, this will be the situation. It's very important. Please do analyze. Just don't write equation and end up with answer. What actually goes on? This is the situation. No? So here it will have velocity, say v dash. Now this will start moving with the velocity. Why it will start moving now? Because the component of tension will act. You can see, I think already we have discussed some similar ideas. Now component of tension on the rod will act towards right. The rod is connected to the plank. So therefore the plank will start moving. So you can give some velocity, v1 dash, v2 dash. Of course, this is a thing. But hanging ball inelastically. Inelastically is understood equal to 0, or I'll give equal to 0 ma. Okay, finish. Why to make a mess of it? Equal to 0. Just after impact, the trolley will be at rest. This is very important. Just after impact, trolley will be at rest. After a certain time, then it starts moving here. So now look at this. It has to complete vertical circle. A perfect inelastic collision. Some of you are getting confusion. So take perfect inelastic collision. And I'll change the data. No, it should complete the vertical circle. This is the thing. So velocity of this be v3. Let the velocity of this be v2. This is L. Is asking what should happen to this particular v. Just able to complete the circle. Just able to complete the circle. So what should be the value of v? Shall we write root 5 GL? Problem solved. Nothing, no. We have all this particular system. Okay, write all possible equations, no. Now, can we apply what is the path of the ball in the ground frame? This bob. Now this will be, I'll call this a bob. What is the path of bob in the ground frame? You know enough of circular motion. Tell me like what's the path of the bob in ground frame? Not circular, but always tension. So what about the role of tension? Tension will act, and tension does positive work on the trolley. Getting the idea? It does positive work on the trolley. You see like the diagram 1, 2, from 3 to 4 you check it. From 2 to 4 you check it. The tension does positive work. The net work done by tension should be 0. So then what about the other thing? So it does negative work on the bob. But sir, you only said in circular motion tension will be always perpendicular to velocity. How you justify here? Because we are going to apply conservation of mechanical engine. Prior to that, what we should be ready with all the things, no? So what is the work done by the tension? Work done by tension in fact 0, because the path will not be circular. If path of the bob is circular, then the tension will be always acting perpendicular to velocity of bob. Work done by tension on the bob 0. Work done by tension on the trolley would be positive. Then we cannot apply conservation of mechanical energy. But here the path of the bob in the ground frame will not be circle. Bob will not move in a perfect circle in ground frame. So therefore, work done by tension on the bob negative, that on the trolley it will be positive. Net work done in fact will be 0. All these backgrounds we are supposed to set up. Net work done. I'll directly come to the sequence here now. Net work done. So apply all conservation of mechanical, conservation of net force on system along x-axis 0. Applying conservation of momentum first between the first and second diagram 1 and 2. mv should be equal to 2mv1. So this is equal to v by 2. And then can we apply conservation of momentum between the second and third diagram? Just I made you to think. So between 2 and 4 you apply the equations. Can we apply conservation of linear momentum here? Yes, it will be. So mv1, so 2mv1, 2mv2 plus mv3, or 2v1 minus 2v2 equal to v3. This is the equation 1, 2. Now check it. What are things we wanted? V, no. For that we to get the v, we should know v1. To know v1, we should have the value of v2, v3. V2, V3 have to be determined. What are the, this is about the condition of linear number. What are other things I can apply here? Condition for circular motion. Yeah, what is the state of tension in the string here? Will be 0, no? Tension is 0 here. Then O will provide required centripetal force, the weight. 2mg will provide required centripetal force. So then any circular motion equation for that, 2mg would be equal to 2m into v2 plus v3 whole square by L. Why this v2 plus v3? Because about point of suspension is what we are writing centripetal circular, the curved path. It will be about the point of suspension about O. What is the velocity of point O? v3, no? And velocity of the bob with respect to point O. Relative velocity apply v2 plus v3. Solving this, v2 plus v3 whole square equal to gl. Keep it here. Then let me apply conservation of mechanical energy. So initial kinetic energy of the bob. I need one more page. I think I'll keep this much of diagram. So now we'll write the equation. Conservation of mechanical energy from between 2 and 4. 2 and 4, conservation of mechanical energy. So what is the kinetic energy of system? 2m v1 square by 2 should be equal to 2m v2 square by 2 m v3 square by 2 plus 2mg. What is the height it will ascend? L plus L, 2L. So what are v2, v3? Velocity of bob and the plank with respect to what? With respect to ground. They are not relative, absolute velocities. v2 and v3 are velocity of bob and plank. Now this is equation 4. Following 1, 2, 3, 4, we'll get the required answer. So velocity, this will be equal to root of 52 GL. V1 should be off of that one, no? V1 should be off of that, and V1 will be root of 13 GL. These are the final answers. Do calculation.